Let us solve one problem from JEST Physics 2023 paper. The problem states that the position and velocity vectors of a particle changes from r1 to r2 and v1 to v2 respectively as the time flows from t1 to t2. If r, t, vt and at are the instantaneous position, velocity and acceleration vectors of the particle, we need to compute the integral I t1 to t2 ra dt, right? So we have r, we have I equal to t1 by t2 means t1 to t2 r t into a t dt, right, where rt is the position vector, rt is the position vector and at is the acceleration vector. So we will recall the identity as dt into r cross v. So we can write v cross v plus r cross a, right? Since v cross v will be 0, so it will be r cross a, right? So we have r cross a, rt cross at equal to d dt of rt cross vt, right? So using the fundamental theorem of calculus we can write, so using the fundamental theorem using the fundamental theorem of calculus we can write t1 to t2 into r cross a dt equal to t1 to t2 d dt of r cross v dt. So we can write is equal to I is equal to r1 t2 minus r1 t2 v t2 minus r t1 into v t1, right? So this means r2 into v2 r2 into v2 minus this is r1 into v1, right? So I is so we get finally we get our required expression r2 v2 minus r1 v1 is the expected result. So it matches with the option A of the r2 v2 is equal to minus r1 v1, option A of the given problem. Hope the problem is clear. So thank you.